Hello, Tom from Every Step Calculus, EveryStepPhysics.com. Think about buying these programs. I mean, why study? It takes me about 3 days to learn these things, related rates. Now I'm an expert at it. But who's got time when you're going to college to do this kind of stuff, memorize this crap? That's the reason I designed my programs, and I got A's in calculus, 20 years ago when they first came out with the calculator. They could find derivatives and integrals and then be able to be programmed, and I was thrilled to death with it. I had no idea what calculus was going on or what anything, nor could I care. And even today, after 20 years, calculus to me finds nothing. It's a Sudoku of math. Should only be taught to math majors. Let them play around with it like imaginary numbers or cosh or sinh and all that stuff that they get into. Not for me, not for you, okay? Anyways, we're doing a related rates problem in calculus with regard to spheres. And I'm going to read the problem. The radius r of a sphere is increasing at a constant rate of 0.04 centimeters per second. At the time when the volume of the sphere is 36 pi cubic centimeters, what is the rate of increase of the area of a cross-section through the center of the sphere? Very important in our lives? I don't think so. Let's do it. Index 8 to get to my menu. I'm going to scroll here to average rate of change rather than related rates, however they're both the same. Average rate of change, I put that in there in case one professor has this words for the same problem in my menu. And then we're going to scroll down here to spheres. There's the formula for the volume of the sphere, which is interesting. And we're asked to find how the volume, we're asked to find the area. Okay, how it's changing the area. So we're going to choose number 1 there. And then they give us the change in radius, so we're going to press alpha first before you enter anything. These iffy lines here is alpha 0.04 centimeters per second, and it's increasing. I'll show you what you've entered so you can change it in case you made a mistake. We say it's okay. It's just like the problem told us. And then it's giving us the volume, number 4. Now in my programs you can press the number on the keypad, number 4 here, or you can scroll down either one. After you get used to my programs a little bit, you're going to be pressing the numbers here because it's quicker, especially when you're doing a test. So the volume is given as, press alpha, 36 times second. The catch that here is the pi, the second register of the calculator. 36 pi cubic centimeters. I show you that in case you made a mistake. I say it's okay. Here's the formula again, and we're going to solve for r because they gave us the volume, and volume equals 4/3 pi r cubed. So we're going to solve for r. Notice how set up this pathetic problem is. Notice 36 here, and when you multiply 36 times 3/4, when you divide by a fraction, you invert and multiply, and we're taking this and dividing this side by that. And of course, we cancel the pi's. They're on both sides, so you can cancel those. And when you do that calculation, it comes up at 27. Isn't that convenient? R cubed to 27 happens to be 3. 3 cubed is 27. So that's cool. Now try it with, 25 or something, some other thing like in real life. Wouldn't work. Okay? So we're going to press enter to continue with the problem. The cross-sectional area is pi r squared. That's the area of the circle. We're going to differentiate that. which equals 2 pi r dr dt with regard to radius and time. So the answer is the area, we enter what we found. Here's 3 for the radius, and here's 0.04 for the dr dt. And we come up with 0.75398 cubic, square centimeters per second. Wow. I'm glad we found that, huh? Hey, go to my site, pretty neat. Go to my site and buy my programs. You'll enjoy them. It'll help you pass calculus. It certainly helped me. Hey, have a good one.